The proof of the addition identity for cosine gets a bit lengthy because of the algebraic details involved. The outline shown here is brief and lists only the main points of the proof. The key to this proof is that the x and y coordinates are the cosines and sines of the angles. The triangles have been created to give us just the correct angles that we need. The two triangles formed, triangle POC and triangle AOB, are isosceles because they are inscribed in a unit circle. Both triangles have congruent angles at point O. The measure of angle COP is alpha plus beta, and the measure of angle AOB is also alpha plus beta. Therefore, according to the side angle side postulate, the triangles are congruent, and it follows that the length of PC is equal to the length of AB. The basis for this proof is the distance formula, and some heavy-duty algebraic simplification is required. We start by using the fact that the lengths of PC and AB are equal. Since the lengths of these two segments are square roots when found using the distance formula, we must square both sides to remove the radical sign. The next step is to square each of the binomials in our equation. If we now regroup the terms as shown, some interesting substitutions can be made. Because the circle used here is a unit circle, it has a radius of 1 unit. According to the Pythagorean theorem, it follows that x squared plus y squared is equal to 1 for each of our 3 points, A, B, and C. Subtracting 2 from each side of our equation leaves us with this equation. Before we finish this proof, let's make some room while saving a few of the important steps so far. What remains now is to substitute the actual coordinates shown in the diagram for the x's and y's in our equation. Next, we apply the reflection identities, changing the cosine of negative beta to the cosine of beta and the sine of negative beta to the negative sine of beta. Finally, by multiplying the sine of alpha times negative sine of beta, we have arrived at one of the addition identities for cosine. Did you understand the broad outline of this proof? Could you follow each step? If not, don't get discouraged. You may have to study the steps of this proof several times before it makes complete sense.